In the previous video, we looked at trying to solve simultaneous equations using our method of substitution. And sometimes we were given a letter to substitute another. Alternatively, we had to rewrite the equation in order to be able to substitute. Substitution will always work, but is it necessarily always the easiest? Well, there's also another method called elimination. The whole purpose of solving simultaneous equations is you're trying to get rid of one letter, turn it into another, and then substitute accordingly. Well, elimination is exactly that. It is the elimination of one variable and being able to substitute into the other. Now, so I'll explain what I mean. I've got 3x plus 2y equals 24, and 3x plus 6y is equal to 12. Now, what I'm going to do is I'm trying to make one letter equal to another. So what I'm going to do is I'm actually going to go and subtract. I'm going to do equation 1, take away equation 2. I'll show you what happens. So I'm going to get 3x plus 2y is equal to 24 minus 3x plus 6y equals 12. Whoop. 3x, take away 3x is just 0. 2y take away 6y is negative 4y. 24 take away 12 is equal to 12. Now I know that negative 4y minus is equal to 12. So all I now need to do is I just need to substitute, so before substitute, just divide both sides by negative 4. So I'll just flap the pages all over the place. Y is equal to negative 3. Now, I know that y is now equal to negative 3. I'm going to substitute y equals negative 3 into an equation of my choice. I am going to choose 1. And primarily, my choice has been whatever's going to have the smallest numbers in the end, because, you know, trying to do things off the top of your head with big numbers is a little bit more difficult. So I'm going to get 3x plus 2 negative 3 is equal to 24. So 3x, positive 2 multiplied by negative 3 is going to be negative 6 is equal to 24. 3x, negative 6, so I need to add 6 on both sides. That's equal to 30. X, divide both sides by 3, and you get x is equal to 10. So my solution is equal to 10, negative 3. But have I just been saying a whole bunch of rubbish? Will this actually be true? Let's prove it. Again, remember, proofs are just optional. This is just to see whether or not what I've just said is nonsense. So I'm going to substitute. So I'm just substituting x equals 10, y equals negative 3 into both equations. And if I get the correct answers, then I know I'm all okay. So 3 times 10 is 30. Positive 2 times by negative 3 is negative 6. 30 take away 6 is 24. So hooray, we proved that one. Let's go with the bottom one. Because remember, we should always prove both in case one of them works, but the other one does not. So 3 times 10 is 30. Positive 6 times by negative 3 is going to be negative 18. 30 take away 18 is 12. Hooray, we have proved it. Excellent. Look at us doing the thing and such. Example 2. Hooray. So example 2 is a little bit different. I've got a 4x plus 2y equals 8, and I've got negative 4x plus 5y equals 6. So if I subtract these friends, like I did before, 4x take away negative 4x is going to make that a positive. So because minus a minus makes that a positive. So I'll end up getting 8x, and I haven't, and 2 take away 5, unfortunately, will just end up with negative 3y, and I'll just end up having 2 letters again. So if I did what I did before, I'd end up with 4 take away minus 4, which is 8x. 2y take away 5y is going to be negative 3y. 8 take away 6 is going to be equal to 2. And this is not equal to anything helpful. So, we're going to try a different tack. I notice I got a negative. Now, what would happen is if I did equation 1 plus equation 2. Hello. 4 plus, so this is 4x plus 2y equals 8. Negative 4x plus 5y equals 6. And I'm going to add these two friends together. So, 4x plus negative 4x. Well, plus and a minus make a minus. So it's going to be 0. 2y plus 5y. 2y. That's what I said there. 2y. 2y plus 5y is going to be 7y. 8 plus 6 is equal to 14. Ah, would you look at this? Divide both sides by 7. And I get y is equal to 2. Fab, go us. So now I'm going to substitute y is equal to 2 into, I think I might go with equation 1 because again the y value was smaller, so I don't have to think too hard because thinking gives you wrinkles. Simpsons reference, never mind. 2 is equal to 8. 4x plus 2 times 2 is 4. 8. 4x, 8 take away 4 is going to make that 4. Divide both sides by 4, get x is equal to 1. Hooray! Good! Now, so that's fine. So obviously if one of them is a minus sign, I could just sort of add the two friends together. Now, what if I've got this nonsense? So, if I subtract these two, I get x plus, what? 2y take away 3y, x minus y is equal to 8. Well, that's not helpful. Nope. If I add, I get 5x plus 5y is equal to 20. That's also not helpful. Because, oh, by the way, that means does not equal to helpful. So I can't subtract and I can't add them. I could alter them ever so slightly, though. Remember how we were rewriting equations and all that nonsense? Well, we could possibly do the same thing here. We've got 3x plus 2y equals 14. What if I was to do something radical? What I wanted to do, you might notice in the other two examples, if we go back, if we just rewind the clock, you'll notice that one of the letters had the same number. So same here, one the other. What I'm going to do is I'm going to do the same thing. And this time, because we've been dealing with x's the last time, I'm just going to choose y's because, you know, I'm an equal opportunity offender here. So what I'm going to do is I'm going to try to make these the same number. And what I'm going to do is I'm going to multiply equation 1 by a number, and I'm going to multiply equation 2 by a number. What do you think I could multiply equation 1 by such that the y's would be equal to each other? What's a common, what does the number 2 and 3 fit inside? Well, they fit inside 6. So what would happen if I multiplied equation 1 by 3, equation 2 by 2, I would get 9x plus 6y is equal to 42. And I would get, so this is going to be 4x plus 9, no, by 2, dear. 2, dear. So 6y is equal to 2. 12. Now, I'm going to subtract, I'm going to label these equations. Have I got some more colours? Oh, I do. Oh, I've got better colours. Oh, go me. That's going to be equation 3. And this is going to be equation 4. So what I'm going to do is I'm going to go and do equation 3, take away equation 4. So plus 6y is equal to 12. 9x take away 4x, it's going to be 5x. 6y take away 6y is going to be 0. 42 take away 12 is going to be 50. Oh, I've just realised what I've done wrong. So, let's go back a bit. 42 take away 12 is apparently 50, according to me. Well, that's handy. Let's fix that up. And let's go back over here. Sub x equals to 6. 12 plus 3y equals 6. Divided by 3, y should be equal to -2. That's better. There we go. Perfect. Okay, so the moral of the story is, even I derp. Well, you already knew that already, but there we go. So yes, please remember how subtraction works. 42 take away 12 is not 50. So, that is that way of elimination. Now, I've also got, let's go back into the clock a bit. Now, you'll notice there I made it such that the y's were equal. Well, we can also do the same if we made the x's the same. So what I'm going to do is I'm going to make 2. Now, you might notice, well, this seems a bit hard. Why don't we just do substitution like we did earlier? Well, you notice that we did. I think we've actually done this question before as a substitution. So I'm going to go and make this, so I'm multiplying all of equation 1 by 2, all of equation 2 by 3. That's better. And that's going to be 18. And then we're going to subtract. This is, that's going to be equation 4. We're going to do 3 take away equation 4. 0 plus 4 take away 5. 4 take away 9 is -5y. 28 take away 18. I hope I get my subtraction right this time. That's going to be 8 take away 8 is 0. 2 take away 1 is 1. So divide both sides. -5. Y equals -2. And now I'm going to substitute y equals -2 into equation 1. I'm going to get 3x plus 2, -2 is equal to 14. 3x, positive 2 multiplied by -2 is going to be -4. 14, going to add 4 to both sides, so you can get 18. Divide both sides by 3, get x equals 6. So yes, you'll notice that with simultaneous equations, there's so many different ways you can do it. Elimination or substitution. I personally like elimination. It's just easier to eliminate, of course, when you don't make arithmetic errors like I did. But it's entirely up to you how you wish to do it.